Okay, so by applying some force, imagine you are accelerating the wedge to the right. Fine. The question is to derive the amount of acceleration A such that the block does not slide along the wedge. So see, some of you may not be able to visualize like how is it possible that the block does not slide along the wedge. Here is what happens. Okay. So if you provide sufficient acceleration to the wedge, it will push the block. You know, wedge will exert a normal force on the block, right? So it's possible that the wedge moves forward like this, and the normal force on the block doesn't allow the block to come down. If you generate sufficient normal force on the block, you can overcome the effect of the force which is pulling it down. So that's the idea. This is how the system should move. As seen from ground. With respect to ground, this is how the system should move. Okay, try this all of you. Derive the acceleration such that the block does not slide along the wedge. Any ideas? What can be done? Okay, listen. The question is about the acceleration of the wedge, which can support the block at that level. Okay. So as seen from ground, this is what should happen. Wedge should go forward. Block should not slide on the wedge. So it stays at that same level. That means block has to go along with the wedge. Okay. Relative displacement or relative motion should not be there between the block and the wedge. So whatever displacement the wedge undergoes, the same displacement the block will also have to undergo. It means with whatever acceleration the wedge moves, the block also has to move at the same acceleration. So imagine the block also to be moving with the same acceleration A. This is all with respect to ground. Can any of you tell me the forces acting on the block?
Normal and weight, sir.
Weight and normal force. Okay. Weight can be resolved into two components. Mg cos theta, mg sin theta. Normal force will be acting. Okay. Now we want the acceleration to be in the horizontal direction, means vertically the block should not move. It should not come down. It should not go up. It should stay at the same vertical level. Horizontally, it should accelerate along with the wedge. Means the vertical forces in this case should balance. Horizontal force should provide the required acceleration to the block. So you can proceed this way. You can take normal force mg sin theta, mg cos theta, take their components in the vertical direction, balance them, and then take their horizontal components and write F net equal to ma, because horizontally it's accelerating. Okay. But a slightly easier way to do would be to consider normal force as it is and don't resolve mg into components. Take mg as a single vector. How does that help? If you take mg as a single vector, you can visualize the only forces acting vertically will be mg downwards and normal's component upward. They should balance. And the only force acting horizontally will be normal's component to the right. Okay, I'll draw the diagram, free body diagram separately. Right. These are the only forces acting on the block. Usually, for our convenience, we resolve mg into two components, one along the incline and one perpendicular to the incline. But this time it is better if you don't do it. Why? Because the block accelerates to the right. Okay, I'll write acceleration separately. And what can make it accelerate to the right? Normal forces, horizontal component. I'll call it as nx. That is what makes it go that way. And normal forces vertical component, which acts upward, we'll call it as ny, balances mg. Okay. And angle made with the horizontal was theta. If that angle is theta, this will be theta, and this becomes 90 minus theta. And normal with the vertical will again make theta. If normal makes theta with the vertical, then the y component will be n cos theta, and the x component will be n sin theta. Once you consider those, you should not consider the original force anymore. And block accelerates to the right. Therefore, we can say that n sin theta, the force acting to the right, is equal to mass into acceleration. First equation. And vertically, it's in equilibrium. Okay. As the block moves this way, it only moves horizontally. It doesn't go up or down. So vertical equilibrium means upward forces should be balancing the downward forces. Upward force is n cos theta. Downward force is mg. Second equation. Our aim was to derive acceleration. So you can take n and a are unknowns here. You can take n from the second equation and put it in the first. Otherwise, you just divide these two equations. If you divide them, n gets cancelled, mass gets cancelled. You get sin theta by cos theta, that is tan theta, is equal to a divided by g. Therefore, the necessary acceleration is g into tan theta. If you make the wedge somehow go with that acceleration, the block can be supported. Okay, the block can be prevented from sliding down. Okay, so look at what we did. You are asked to derive the acceleration such that the block does not slide. First, visualize what is happening. Block should not slide. Wedge is accelerating. That means the block has to accelerate along with the wedge. Block can't stay there itself. No, it should go along with the wedge. Which means whatever acceleration the wedge has, the block should also have the same acceleration. And then we considered the forces acting on it. Wrote F net equal to ma. We got the acceleration needed. Is this clear to all of you? If you have any doubts, you can ask. Okay. Pawan, tell me, wedge is accelerated here. Block has to move along with the wedge. It should not slide along the wedge. So relative to the wedge, how does the block appear to move? Like if you observe all this with respect to wedge, what will it appear like?
Sir, it stays constant and ఎక్కడ కదలకోకుండా.
It stays at rest. It will be in equilibrium. Okay. So if you visualize the same situation with respect to wedge, the wedge will anyway be stationary. And just a minute. Yeah, with respect to wedge, the wedge will anyway be stationary, and we don't want the block to slide on the wedge. So block will also be at rest. It has to continue to be at rest with respect to wedge, means it should be in equilibrium. Okay. Can this force and this force balance? I'm asking all of you, can a force directed this way and another force directed this way, can they balance?
Sir,
No,
no.
sir.
No. Then how can the block be in equilibrium?
Pseudo force.
Yeah, there must be some other force involved, and the wedge here is accelerated, right, with respect to ground. So it's a non-inertial frame. And if you want to explain what is happening in a with respect to a non-inertial frame, you need to sorry. You'll have to consider a pseudo force. Tell me the magnitude and direction of pseudo force.
M into A, sir.
Which way?
Left, sir.
To the left. Correct. Mass of the object multiplied with acceleration of the reference frame. Now, acceleration of the reference frame is what you are asked to calculate. Okay, so we'll take it as A, and we have to consider pseudo force in a direction opposite to the acceleration of the frame. So it will be to the left, this way, MA. And these three forces, they can balance. It's possible. So we just need to write equations for vertical equilibrium and horizontal equilibrium. Now we already know that this angle is theta. So n cos theta, that's the upward component of normal force, balances mg, and the force to the right, n sin theta, balances the pseudo force, ma. That way, acceleration of the block can become 0. And if you see, these are the same equations that we got before when we solved the problem relative to ground. Okay. So you can solve problems from the ground frame itself, but some situations will be easier to analyze and write equations for if you make one of the objects the reference. But if that object is accelerated, then you'll have to apply a pseudo force to explain what is happening. Okay. Try this question, all of you. a slightly complicated situation. Visualize carefully and answer. These two blocks are placed side by side, just in contact with each other. The bigger block has a pulley attached to it. And let's say there's a rigid support on this side. There's a rope. Okay, rope I'll take in gray color. Fine. This is the situation. All surfaces are smooth. Okay. Now you can assume masses also to them. Let's say their masses are some 4m and m. Visualize and tell what happens first after this system is released from rest.
సార్ మాసం కిందకి వస్తుంది ఇంకా 4M అంటే లెఫ్ట్ వైపు వెళ్తుంది.
Okay, so Pawan is saying mass m descends, so moves vertically downward, and 4m moves to the left. Any other answers? What will happen to this system after it is released from rest?
So that only, sir, it'll go down the mass.
Okay, will it continue that way? I mean, till when will it continue that way?
Sir, until the block M reaches the ground.
Okay, others, what do you say? Till when will m continue moving only in the downward direction?
సార్ మాసం కిందకి వచ్చిన 4M అనేది లెఫ్ట్ సైడ్ వెళ్ళచ్చు కదా ఇంకా.
4m will move to the left.
Sir, but I think before reaching the ground, I think at a point it'll stop going down.
Why?
Sir, I'm not sure about the reason, but that's what I'm thinking. I'm trying to figure out the reason.
Like, what could stop it from going down? What makes
Unless
it?
and until there's a weight like near the starting of this thing. No, sir, it'll go to the ground only. So,
Okay, so I want to confirm. So are you all saying the block will follow this path till it hits the ground?
yes, sir.
Okay. Aishwarya, what do you say?
So the same.
Sir, but with respect to the ground, I think the block M will move like with an angle.
See, initially it may start moving only in the downward direction, but when the block goes aside, like the big block, just a moment. The pulley is attached to it, right? So when it goes to the right side, left side, imagine it to be somewhere here. Then by then the block would have, I mean, if the string remains vertical, if the part of the string connected to the block remains vertical, then this is what should happen. Yes or no? Rishi, what do you say?
Sir, yes.
Okay, if that part of the string which is connected to the small block remains vertical throughout, then this is what should happen. Okay, I'll remove that original this thing. Right. So the block M cannot always move only in the vertically downward direction. It has to move to the left also. Okay, because the supporting pulley is going to the left along with the bigger block. And there's no reason why this string should continuously remain vertical. Okay, it can tilt at an angle. We'll discuss in detail. But see, as always, the question was to determine what happens to the system after it is released. The first thing you need to think about is the forces acting on the objects. Tell me what forces act on small m, the small block.
Weight, normal, and tension.
Weight, normal, and tension. So you are thinking they'll be pushing each other.
No, sir.
There's no reason why they should push. No, this string is vertical. Fine. So had the situation been something like this, let's say there is a block on the side and the block is connected to a string somewhat like this. Then maybe due to this tension leftward component, the block presses the bigger block. Something like that could have happened, but these two are simply side by side. Okay, so there's no reason why they should push each other. Okay? They won't
Sir,
also.
then how 4M will move
Uh-huh.
towards the left?
That will be my next question. We'll discuss that in detail. Okay. We'll consider normal also. You will see that normal becomes 0, or you should not consider normal in this case. You'll understand. So yeah, on the block, small block, its weight will be acting. And because there is a string connected, definitely tension will be generated in that string. Okay. Now, if you consider a normal, then on the small block, it should act to the right, which means the small block should move to the right. Obviously, there won't be anything to counter this. Then the small block should move to the right. How is that possible? Do any of you think it can happen? Do any of you think the small block will go to the right?
Sir, it'll be like many, very, very minute. Like,
So you're saying it will
because
go.
when the 4M mass like moves to the left, it'll slightly go towards the right.
No. See, you all need to be very careful here. I understand what you are saying, but you are not talking about the reference frame. You are saying when 4M moves to the left, a small gap will appear between them. Yes or no?
Yes, sir.
Ha. Gap appears. Okay. Okay. Just a moment. Let me adjust the diagram that way. Let's say 4M moves to the left a little bit. Situation will be somewhat like this. Okay. See, a gap appears between them. That doesn't mean small m has gone to the right. Okay. Even if small m there stays at its own place, okay, horizontally, means wherever it was initially, if it stays at the same position also, that gap will appear. Now, why some of you feel like it goes to the right is because relative to the block, it goes to the right, not with respect to ground. Okay. And relative to block, we can explain. Block is accelerating to the left. No. Now, why it is accelerating to the left, we'll discuss. But if you all are convinced that block will go to the left, if block accelerates to the left, you'll have to apply a pseudo force. Relatively, you'll have to apply a pseudo force because block is an accelerated frame. It's a non-inertial frame. So when observing small m from bigger block, you'll have to apply pseudo force, and you can say that pseudo force is making it go away from the bigger block. That makes sense. But with respect to ground, what will make it go to the right? It won't go to the right. Okay, that going to the right is relative to the wedge, bigger block, not with respect to ground. Or okay, wait. Before we get back to this problem, let's solve another problem, a different one, just to give you some more clarity on how objects move. Diagram, I think we can use. Okay. Okay. So suppose there's a container, cabin, car, you can consider it whatever you want. Okay. Initially system is at rest, and inside the container, there is a pendulum suspended. Okay. You can assume mass of the bob of the pendulum to be m. Assume everything was at rest initially. Now, suppose the container starts accelerating to the right. Okay, we push it and somehow make the container move forward. What will happen to the bob? If the container starts moving to the right. Starts moving means it is gaining velocity, means it is accelerating. Okay. What happens to the pendulum?
Well, the pendulum will go to the left first, and then it'll go to the right.
Okay, so you were saying it will swing, but it will go to the left first.
Yes, sir.
What force could have made it go left? First, tell me the reference frame with respect to which you are speaking. Are you trying to say what happens as seen from the ground or as seen from the container, or both will be same? Others also think about it carefully.
Sir, I'm talking about the reference from which we look from, like the outside.
From outside, from ground.
Yes.
Okay.
Yes, sir.
So, Rishi, tell me what could make the bob swing to the left? What means which force?
Sir, the pseudo force, like the component.
Why will
of
you consider pseudo force from the ground reference frame? You should take pseudo force only when you are observing from non-inertial frame, no?
Yes, sir. Oh, yeah.
Then others, how will the bob move?
Here the bob remains stationary.
So container will go off, but the bob will stay there itself.
No, there's no force acting on it, no, so then why will it move?
Okay, fine. Correct. What you're saying is correct only. But what you are saying is correct only for the first instant. Okay, only for the first moment the motion starts, the bob will not move, the container will move. The next instant onwards, the bob also will start moving. Actually, I'm trying to show this. If any of you have a thread with a stone connected to it or anything, even your ID card or something, you can try. Just a moment, I'll bring my ID card. If I'm sure you all must be having an ID card or something of that sort, no? Any object suspended from a thread. So what I want you all to do is hold the tip of the thread, make that ID card or whatever bob is there with you, make it stationary. Okay. And ask someone or you yourself, like suppose there's a bob suspended here. Keep the pen exactly where the bob is initially. Fine. Now keep your eyes on the bob. The pen shows you the position of the bob, right? So don't move the pen. You start moving your other hand. You accelerate the point of suspension. See if the bob or ID card ever goes back or only goes forward. Okay, observe that. I'll come back in a minute. Did any of you try? This is also a very common misconception actually. People think it goes to the left. It does not. Okay, consider this. I got some suspended object. Okay, you should be able to see my hand also. So this is the point of suspension, my finger. Okay, this is the object whose motion we'll be considering. It is rotating, okay, but I mean, it's rotating, spinning, but it's not moving forward or backward. That is, I'll try not to make it move forward or backward. Okay. So this is its position. The pen marks the position of the object suspended by a string. Now, if I'm going to start or I'm going to move my hand this way. This is right to me. Okay. This is the position of the object. So if we move it to the right, okay, actually, if you see in slow motion, you'll understand better. The object will not go to the left at all. Okay, suppose it is stationary here. I move my hand to the right, the object goes to the right only. Okay, while going to the right, the string will bend. Okay, it will tilt at an angle and the object goes this way. Fine. So actually what happens initially, when the object is at rest, initially when the container is not moving, so point of suspension is also not accelerated. At that instant, what happens? Can one of you tell me what forces act on this object?
Tension
The
and weight, sir.
gravitational tension.
Weight and tension will be acting. Weight is vertically downward, tension is vertically upward. They'll balance. Is there any horizontal force acting? No. Okay, we are seeing from the ground reference frame only. Okay, whatever you are observing is from my laptop camera, which is fixed. So the frame of reference is fixed. It's not an accelerated frame. So inertial frame only you are observing. So you should not talk about a pseudo force. Okay. So its weight is balanced by tension. There is no horizontal force. That's why the object does not accelerate to the right. But the moment the point of suspension starts moving to the right, the next instant, okay, maybe this is better. The next instant, my finger, which is the point of suspension, goes to the right a little bit like this. Then the string tilts. When the string tilts, there will be a horizontal component of tension. It's at an angle now. Tension acts at an angle now. It has a horizontal component. That is what pulls the object to the right. Okay, in the same direction in which the container moves. There's no reason why it should go to the left. Okay, so initially it's like this. The next moment it will be like this, and then it starts moving to the right. Okay, now why some of you feel it moves to the left is because relatively it goes to the left. Okay, as the object is pulled forward, you see where my right hand has gone. Initially, my right hand was exactly above the object. The point of suspension was exactly above the object. But later, as the object moves forward, the point of suspension is ahead of the object. Okay. So relative to the point of suspension, the object has gone to the left. But relative to its original position, it has gone to the right only. So situation is something like this. Originally, both were here. Okay. Later, this is what happens. Object goes, point of suspension goes, but point of suspension goes more than the object. So relatively it appears to swing to the left, but actually it has gone to the right. Okay, swing is to the left only. Swing is relative to point of suspension. With respect to ground, it goes to the right. This is right for me. Okay. So did you all understand what happens? You can try it later if you want. Just take some suspended object and try it. Lesser the disturbance, the better. Okay, so what Vanilla was saying was mostly correct. Initially, there's no force acting horizontally. Why should it move horizontally? It won't move. For the first instant, it is correct. The next instant, what happens? Assume the container has gone forward a little bit. Then the string tilts a little bit in the direction in which the container has. Okay, the point of suspension moves in the direction in which the container moves. Now the tension is no longer vertical. It will have an X component that will make the bob accelerate to the right. Okay, after some more time, you may see something like this happening. Okay, so with respect to the container, it swings to the left, but with respect to ground, it accelerates to the right only. Just a moment, I'll try to put all three in one frame. I don't think it is possible. Never mind. This is what happens. Okay. And if the container continues accelerating that way, the bob will swing and finally settle at one position. Okay, it will come to equilibrium with respect to container at one position. Position means at one particular angle with the vertical, it will settle. The question is to derive that angle. Okay. So just a moment. Container has an acceleration A. The bob swings inside the container and finally settles with respect to container. Okay. At some angle theta. Derive the angle theta at which the bob settles with respect to the container. Try this, all of you. Settles means comes to equilibrium with respect to container. Any answer?
Tan theta equal to G by A. So A by G.
Tan theta equal to A by G. We'll see. Others, any answers? Okay. Pawan, can you unmute? How are you trying to solve?
Sir, tension components తీసుకుని try చేస్తాను sir.
Correct. Okay. See, again, here you can choose the reference frame. You can write equations with respect to ground, you can write equation with respect to container also. Now, with respect to container, the bob settles, means it will be in equilibrium. But with respect to ground, it has to move along with the container. Okay, what I mean is, finally, when the bob settles somewhere, they'll be moving like this. Container will move, the bob will move along with the container. Like the question that we first solved today, wedge moves, block has to go along with the wedge. Okay, so same thing here. Container moves, the bob has to move along with the container. So this is as seen from ground. Let's write equations. Now, if the bob has to move along with the container, the bob should have an acceleration a to the right. Okay, and as seen from ground, the only forces acting on it would be mg and tension. String makes an angle theta with the vertical, so tension also makes an angle theta with the vertical. Then this component of tension would be t cos theta, and the horizontal component of tension would be t sin theta. The bob only moves horizontally, it doesn't go up or down. Therefore, t cos theta should balance mg, and t sin theta f net equal to mass into acceleration. Solve these two, you will get tan theta is equal to a by g. Okay, or a is equal to g tan theta is equal to a by g. Now, if you see with respect to the container, with respect to container will be stationary. But container is a non-inertial frame, so you will need to apply a pseudo force. Container will be stationary, bob will also be stationary, but you will have to consider a pseudo force, mass of the bob multiplied with acceleration of the container, and along with that its weight and tension will be acting, mg, t. I will take components t cos theta and t sin theta. That's all. The equations will again be the same. T cos theta balances mg and t sin theta balances ma, pseudo force. Same equation, same answer. Tan theta is equal to a by g. Okay, so it is a common misconception that people think the object moves to the left. Object does not move to the left with respect to ground. There's no force to the left. Why will it move to the left? Okay, with respect to container, it swings backwards, swings to the left. That is okay. But with respect to ground, if you see, it will be going forward only. Hope this is clear to all of you. Let us go back to that question now. So here there will be a gap developed between the big block and the small one. Let's call them A and B to avoid confusion. There will be a gap developed between A and B. Doesn't mean B is going to the right with respect to ground. With respect to A, B goes to the right. Okay, a little bit it will go. Definitely that gap will appear, but not with respect to ground. Is this clear to all of you? If you have any questions, you can ask. Okay. Anyway, here also the question is to find out the accelerations of A and B as soon as the system is released. Normal force, yeah, we were talking about that. Some of you said there may be a normal force between A and B. There will not be a normal force, because had there been a normal force, the block would have gone to the right, which does not happen. Why should they push each other? There's no reason why they should push. Is the bigger block A trying to go to the right? Why will A push B? There's no reason. Okay, they're simply staying side by side. If A tries to go to the right side, then it will push B, it will exert normal force. Here it will not try to go to the right. Why will it try to go to the right? Okay. So these are the only forces acting on B, tension and weight. And under the influence of these forces, it can only move vertically. It won't move horizontally. Later, it may move horizontally when the string tilts next instant. Okay, the second instant onwards, when the string tilts like this, tension's component can make it move to the left. Okay, can make the small block move to the left, but initially it won't move to the left. It will start going down first. Okay. Now the question arises, then what makes the bigger block go to the left? Any idea, anyone? What makes A move to the left?
Sir, I think the pulley will move towards the left. That's why 4M will move.
What makes the pulley move to the left? See, it's like I'm telling this to all of you. Pulley is connected to the block of mass 4m. So it's like pulley and block are one system now, one object now. Anyway, uh, you are thinking pulley has a tendency to go to the left. That's why the block goes to the left. Correct only. What makes the pulley go to the left?
Sir, string.
String. Correct. You have to consider the forces acting on the pulley. Initially, this part of the string is horizontal and this part of the string is vertical. Just at the moment of release, this is what the situation is like. Okay. So on the pulley, there will be a tension this way and also this way. This tension which acts on the pulley and 4m are like one object now. Okay. So this tension is what makes 4m and the pulley accelerate to the left. Is this clear to all of you? You can visualize it like this. Let me help you understand. Just a moment. Suppose you were simply holding the small block on the side of the bigger block. I mean, just beside the bigger block like this. Okay. The string is just touching the pulley. It's not making any angle or anything. Does it appear vertical? Just a moment. Let me adjust. Somewhat like this. The block is connected to the string. Small block. This is the situation. Okay. Suppose you are holding the string here. What will happen now? Nothing. Small block stays there itself. Tension balances its weight. Big block is not under the influence of any force. I mean, weight and normal from the ground will be there. No additional forces. Big block will be in equilibrium. Everything will be in equilibrium like this. Now, you try to move this point of suspension to the left. Then what will happen? The string will start getting bent near the pulley. Okay, string will start bending near the pulley. This part of the string may remain vertical, but the upper part bends. Will the bigger block start moving to the left or not? When the string bends near the pulley.
Yes, sir.
It will. Okay, if this is a perfectly smooth surface, the bigger block will slide to the left. And see, in the initial situation, there are two, let's consider these as two cases, case 1 and case 2. Case 1, why it was not moving to the left? There was no force to the left. Case 2, from everyday experience itself, we can tell the block will move to the left, bigger block. And what is the only possible explanation we can give to that? This tensions component must have been making it accelerate to the left. And that is what happens in this problem. The tension in the string will make the pulley along with the bigger block to accelerate to the left. Okay. Fine, then you can simply write equations and most important will be the, okay, let's see. Try to solve this, all of you. Calculate accelerations of the blocks. A and B. Answer will be in terms of G. See, masses are not given in numbers, right? Numerical values of the mass are not given to you. So G also, you'll take it as G itself. Don't substitute 9.8 or 10. Try this, all of you. Actually, in this case, you don't have to apply pseudo force and all. With respect to ground, you can solve it off. Derive the accelerations quickly. Any answer, anyone? At least tell me the equations that you wrote. I got one answer as 2 meter per second square. We'll see. Pawan, tell me the equations that you used.
Sir, mg minus t is equal to m.
Okay, for small block, you would have written downward force mg minus upward force tension is equal to mass into acceleration. For the bigger block,
T is equal to 4m.
on the bigger block, the only force making it accelerate to the left is tension. Okay, there's no normal force between the blocks. We have decided that. There's no reason why they should push each other. Okay, so the only force which makes the bigger block accelerate to the left is tension in the string T. So you'll get T is equal to 4m A. But Pawan has overlooked one point here. He took accelerations for both of them as A and A. Pawan, are you sure that their accelerations will be equal?
Yes, sir.
How?
సార్ అంటే స్ట్రింగ్ కదా సార్, అంటే
Ah.
m ఎంత కిందకి వెళ్తుందో 4m కూడా అటు సైడ్ లెఫ్ట్ హ్యాండ్ వెళ్తుంది.
Okay. Since there is only one string, by whatever distance 4m moves to the left, by the same distance m comes down, you are saying. Okay. But listen, there's something to be discussed here also. Only for the initial instant, their accelerations will be equal. Okay. You imagine, see, this is the initial position, we know that. I'll just show the pulley and the string. I'll remove the other parts of the system. This is the initial situation. A moment later, okay, moment later, actually, we won't be able to visualize, but let's take some significant displacement of the big block to the left. In fact, let's not see the block also. Okay. Now, the big block, let's say, moves to the left by some distance x. If it moves to the left by some distance x, this part of the string will be free and that will come down on the other side. So on the other side, what will happen? I'll mark this part in red. That red part will be seen here. Okay, so how much ever distance the bigger block moves to the left, by the same distance, the smaller block descends. Right, because the length of the string should remain constant. Then we can say that their accelerations are equal. Okay, good that you considered that factor. Generally, when you solve such questions, no, you should take accelerations a1, a2 and derive the constraint. Here, the constraint is that their accelerations are equal. a1 is equal to a2 is equal to a. Okay, solving these two equations, you can find out the tension. You can even tell the acceleration of the blocks. But all this is valid only for the first instant. Next moment, the string will get tilted. Then things will become complicated. When the string gets tilted, why things get complicated also, I'll show you. On this block, tension will act at an angle now. So you'll have to take the component of tension upward, mg. These two will give it vertical acceleration. And the horizontal component of tension will give it horizontal acceleration also. The block will start getting horizontal acceleration the next moment onwards. That makes it complicated. And for the big block also, there is tension this way. There is also tension this way. Okay, initially also it was there. There is tension to the left. There is tension downwards on the pulley. Why did we not consider the downward tension? We did, but since the acceleration is to the left, only this tension mattered. Okay, but the moment the string makes an angle with the vertical like this, you will have to consider both of them. One strictly acting to the left, other acting at an angle like this. You will have to take its component to the right. Of course, we don't know the angle, so you won't be able to write the component properly. Tx, then you should write t minus tx is equal to 4m multiplied with acceleration of 4m. Okay, so the next instant onwards, it gets complicated. Okay, fine. We'll stop it here for now. Tomorrow's class, we'll start discussing conservation of linear momentum. Not tomorrow, Monday's class. Okay. If you all have any questions, you can ask.